Scientists are toolmakers. Nuclear scientists are using insights from studying life at the atomic level to develop innovative tools that will help governments tackle our 21st century challenges and achieve the UN's Sustainable Development Goals. A growing population with a significant disease burden and limited resources living in a polluted world. Today's complex problems need inventive solutions. Nuclear science is already providing the technological breakthroughs that can give us hope for tomorrow. In the 20 million strong metropolis of modern Mumbai, life is a constant whirl of activity. But despite the crowds and commotion outside, in this room everything is calm, precise and controlled, allowing doctors to target cancer tumours with millimetre accuracy.
Stereotactic radiation is known to be as precise and effective as a surgical knife in many types of cancer, and right now we are testing its performance for inoperable liver cancer.
This advanced form of radiation therapy is possible because of improvements in medical imaging, which allow a doctor to map out the exact contours of a tumour and use this 3D outline to shape radiation beams. During therapy, the patient lies on a custom-made body mould and uses sensors to monitor and control their breathing to minimise any movement during treatment. This immobilisation, combined with precise targeting, means the beams are less likely to damage surrounding tissue, so the doctors can deliver much higher doses of radiation. This makes treatment faster and more effective, with less side effects, and in some cases can buy even an advanced cancer patient valuable time. Deep inside this concrete labyrinth, a linear accelerator is creating radiation, which is used to battle some of the world's most toxic pollutants. Electron beams are already a proven tool for treating industrial wastewater, such as from the textile dyeing industry.
Many complex chemicals cannot be broken down by bacteria in the normal wastewater facilities, so they are very hard to dispose of. However, electron beams are powerful and effective in breaking down their chemical bonds, allowing us to discharge them very safely.
This technology can also be used to clean even more toxic materials. For example, in Slovakia, a channel contaminated with the cancer-causing chemicals known as PCBs is feeding into the huge Lake Zemplin. Local scientists who have been using E-beams to sterilise medical equipment have now set their sights on a more ambitious goal.
We want to use the radiation to clean the polluted mud before it gets to the lake. We are bringing samples of the mud to our laboratories, irradiating it, and we are already seeing strong results.
The team hopes that irradiating the contaminated river mud on site will stop the slow trickle of pollution into the lake. Using E-beams for treating the most tenacious industrial pollutants is fast, effective and ecologically sound, and could offer a sustainable solution for governments and industries. Innovations in plant breeding are speeding up the rate that better crop varieties can be developed to reduce global hunger. For nearly 100 years, gamma rays have been used to safely induce mutations and enhance the genetic diversity of crops like barley or quinoa. Mutation breeding has already developed thousands of improved crop varieties with valuable traits for farmers, such as resistance to disease or tolerance to drought. Nuclear scientists are now taking a new approach, using genetic markers to find the chosen mutant trait, so that breeders don't have to grow several generations to find out if a plant has the desired mutation.
It's something that can accelerate and enhance the impact of mutation breeding.
The goal is to be able to quickly identify a positive trait in a mutant plant and then introduce that trait in other varieties.
What we hope to say to the member states in the future is, first of all, that we'll have a toolkit that allows to introduce traits that they're interested in into their locally adapted varieties. And then, equally important, I think that we can provide the trainings on how to do it themselves in the future.
A global project to track the journeys of specific raindrops is harnessing the power of big data to monitor water supplies for our thirsty planet. Every month, for over 50 years, researchers have gathered rainwater from stations like this in Vienna and hundreds of other sites around the world. The unique isotopic signatures or fingerprints of each rain sample are recorded, and this information is entered into a large online database where it's compared to similar data from surface water to see which raindrops end up in which rivers.
This large amount of data allows researchers to better understand the water cycle. For example, how, when and where water is recharged. This information is key for managing water resources, especially in the light of climate change.
The datasets and maps are available to download for free and can be used in many ways. For example, in Costa Rica, where they're helping the government identify key locations to protect groundwater so they can target conservation measures and avoid drought.
We now know which areas need special attention. We know how to protect them to ensure water supply for now and the coming decades.
How can scientists trace a barely visible plastic particle across the ocean through a fish's body and onto our plates? Microplastics in the seas now outnumber the stars in our galaxy, but we still don't know exactly where these tiny pieces of rubbish end up, or what effect they're having on fish or the humans who eat them.
Nuclear techniques are a very useful tool in the research of microplastic particles in the ocean because we can follow microplastic particles through the food chain.
Radio tracers enable scientists to investigate whether the particles are crossing cell membranes. For example, from a mother shark through the egg case to a baby shark. Or through a fish's food, such as these shrimp, into its digestive system and possibly into its brain or other organs. And they can see whether plastic pollution affects the way a fish absorbs nutrients or contaminants. This research is still new, but offers hope that we can better understand the effect of microplastics on marine life, because we can't solve a problem we don't understand. The power and precision of nuclear science, technology and their applications give us innovative tools in healthcare, agriculture, industry, water security and ocean research, among others. The IAEA's Technical Cooperation Programme helps deliver these tools to member states, who ensure the science is directly applied to improve people's lives. And the cutting-edge techniques showcased here are just a small sample of the many tools nuclear science can offer the world. Together, these atomic advances give us hope that our considerable global challenges can be overcome.